Hello viewers, welcome to this video. Today we're going to take a look at Longhorn, which is a cloud native distributed block storage for Kubernetes. So the way it works is basically it is going to use the storage that's available in your Kubernetes nodes to provision persistent volumes. In addition to provisioning the volumes, it also replicates the volumes across multiple nodes. So if a node goes down, your data is still accessible for your pods. And if the crash node comes back online, the data is going to get synced again from the other volume. So you can configure how many replicas of your volumes you want. And the other cool thing is you can set up snapshots, you can take backups, you can also configure scheduled snapshots and backups. And this project was originally developed by Rancher and now it's a CNCF sandbox project. Right, for this video, my setup is going to look like this. And I've got a Dell laptop with Arch Linux installed, 8 CPU, 16 gig of RAM, and I've deployed a Kubernetes cluster version 1.21.0 using Vagrant with KVM and libvirt, and these nodes are all Ubuntu 20.04 with containerd as the container runtime. And in addition to that, I've also deployed Metal LB for load balancing solution. So longhorn.io, that's the website if you're wondering. I'll put a link in the video description. Let's go to the documentation. The latest as of recording this video is 1.1.1, and I'm gonna go straight into the installation documentation. So basically you've got three ways of installing. If you're already using Rancher to manage your Kubernetes cluster, you can use the Rancher UI. You can go to the app catalog, find the Longhorn project, find the Longhorn app, and then configure. So going to the app catalog, search for Longhorn, put in some configuration values, and there you go. So that's the easiest way. But if you're not using Rancher, you can use kubectl command, a simple command, and that will deploy all these resources. So a service account, namespace, cluster role with these privileges, cluster role binding, and a bunch of custom resource definitions. But my preferred way is going to be Helm. I'm going to be using Helm for deploying Longhorn in my Kubernetes cluster, but before that you need to make sure there are satisfy certain prerequisites in all the Kubernetes nodes that you want to use as storage nodes. Right, so the installation requirements are Kubernetes cluster version has to be 1.16 or above. I've got both that satisfied, and if I do Helm version, so my Helm version is 3.6.1. If I do kubectl get nodes version 1.21.0, which is good, kubectl get nodes -o void, and I'm running containerd version 1.4.4, so that's also good. And apart from that, you need to install OpenISCSI package, whether you're using Ubuntu as your Kubernetes node or CentOS based, RPM based. You need to install the OpenISCSI package and also NFS version 4 client. All right, I'll do that in a minute, and it only supports ext4 or XFS file system, and you also need these little utilities installed on your Kubernetes nodes. So if you're using my Vagrant environment with Ubuntu 20.04, then you already have all these utilities installed, and OpenISCSI is also installed. The only thing we need to do is install the NFS4 client, and you also got the commands here if you want to install OpenISCSI depending on the distribution. If it's SUSE or OpenSUSE, using Zipper, and then for Debian Ubuntu it's OpenISCSI package. For RPM based it's ISCSI initiator utils, and the NFS version 4 client, if you're using Debian or Ubuntu, it's NFS common, otherwise it's NFS utils. All right, so first we'll make sure that we've got all the prerequisites in our Kubernetes nodes. Right, let's log into kworker1. I'm not going to touch the kmaster because I don't want to deploy any stuff in the master node in the control plane. So all I'm going to do is just do all these things in the worker node, kworker1 and kworker2. Right, if I do dpkg -l, query the package and grep for ISCSI, and you can see OpenISCSI package has already been installed on my Ubuntu 20.04 machine. Otherwise it's just apt install OpenISCSI. Right, I'm not going to install that. And also we need to make sure that the ISCSI daemon is running. So if I do systemctl status ISCSI d, it says it's disabled, but it can be triggered by ISCSI socket. So that's well and good. You don't have to enable, you don't have to keep it running, but it can be triggered by the socket. So that's good. And I'm also going to check if I've got the NFS common package installed. If I grep for NFS common, it's not there, so let me install that. Apt install NFS common. Right, that's installed. I'm going to exit out of it and going to log into the other worker node and install NFS common. Apt install NFS common. Cool, so that's installed. I'm going to exit out. Right, back in here, let's go into Helm, which is my preferred way. And if I go to Helm, so Helm version 2 or above must be installed on your workstation, and you have to make sure that all the system level prerequisites has been satisfied, which we've done just now. Right, the first thing is to add the Longhorn repository. Let's do that. Done, and do a Helm update. Helm update. Helm repo update. Helm repo update, that's done. And the next thing is to install. If you're using Helm version 2, I would be surprised if you're still using Helm version 2, but if you're using version 2, then this is the command to install Longhorn. But if you're using Helm version 3, you can use this command. Okay, let's do that. And if I do Helm search repo Longhorn, so we've got one chart in the Longhorn repository, and the app version is 1.1.1, which is the latest. And as you know, I won't blindly install any Helm chart. I would first download the values file and see what I can actually configure before installing it. So for that, I'm going to do Helm show values, Longhorn the repository name, and Longhorn is the chart that we want to install, redirecting that to a temporary file. And if I take a look at the temporary file, you can see the list of things that you can configure, but I'm not going to change anything at the moment. But I just want to keep that values file handy, because if in the future, if I want to change anything, this is my single source of truth. So we've got our values.yaml file. Now I'm going to install Longhorn. But before that, let me show you what I've got in my Kubernetes cluster. If I do kubectl get pods, so nothing fancy, it's the usual set of Kubernetes system pods. And in addition to that, I've also got pods related to Metal LB. That's it. And if I do kubectl get namespace, these are all the default namespace apart from the Metal LB system namespace. Right. Helm install, so that's a long command. This is for Helm version 3, Helm install Longhorn. So that's the name you give for this release installation. So it can be any name, and the repository and the chart that you want to install. Pass in the values file that you just downloaded. And I want to deploy this in a namespace called Longhorn storage, which is not created yet. So I want to use this option -- create namespace, which will create the namespace before deploying. Otherwise, you will get an error. Or you could create the namespace yourself by hand. Right, Longhorn storage. I prefer to use Longhorn storage, but the documentation they're using Longhorn system. But anyways, let's do that. So that's all you need. And it's going to deploy a bunch of resources, right? So if I do kubectl -n Longhorn storage get all, so you can see it has only created 4 pods, but once it's complete, give it like 3 or 4 minutes, and then you will see a huge list of pods here. Right, so I'm going to pause the video here and come back in about 3 to 4 minutes time to show you the entire resources that it has deployed. All right, I think it has completed. Let's check it now. Yeah, you can see here a whole lot of pods, and then we've got a bunch of services, list of daemon sets, and then a lot of deployments and replica sets. Okay, so the interesting thing here is you need to wait for all the pods to be running, and then the UI, the next thing we're going to do is to access the Longhorn UI. And the service that provides access to the Longhorn dashboard is this Longhorn front end. And if you see here, it's of type cluster IP, so you can't access it from outside the Kubernetes cluster. The quick and easiest way to access the Longhorn dashboard is by port forwarding, quick and easy. Or you can change the service type to load balancer or node port. Because I've deployed Metal LB in my cluster, I can change the service to type load balancer. But let me first show you the port forwarding method. kubectl -n Longhorn storage, port forward, service Longhorn front end. I'm saying the port 8080 on my local host should be forwarded to port 80 on this service, which then forwards it to the Longhorn UI pod here. Right, so if I run this port forwarding command, so now I can go ahead and access localhost :8080, and that will take me to the Longhorn dashboard. Let's try that out. Localhost :8080. And that's the Longhorn dashboard. Okay, let me close that, and I don't want to do this because I've got MetalLB installed. I'm going to change this Longhorn front-end service from cluster IP to load balancer. Again, I can do kubectl -n Longhorn storage edit service Longhorn front-end and change it from cluster IP to load balancer. But when I do a Helm upgrade again, then this change will be lost. So this is why I want to capture every change in the values.yaml file, which is the single source of truth that I've saved in my source control system. Right, so now I can edit my Longhorn values.yaml file, and if I scroll down a bit, there will be a section called service, and UI type is cluster IP. If you want to change this to node port, you can change this. You can set the value to node port and set the node port to be something like 32323 or whatever you want to configure. But since I've got MetalLB installed, I can set this to load balancer type. Save this. So now we've updated the values file. Now I need to update the Helm deployment, the Helm release. Right, the command is going to be the same. Instead of Helm install, I'm going to use Helm upgrade -install. It's the same command, -install, and everything is going to be the same. Longhorn storage. This time I'm not passing --create namespace, which I passed in the first Helm install command. All right, so that's the only difference. Right, so that's done. And if I take a look at Longhorn storage get service, you can see Longhorn frontend is now of type load balancer, and I've already got the IP of my load balancer. So I'm going to copy that. I'm going to edit my etc host file. I'm going to say 172.16.16.240 and Longhorn. Right, so I'm making an entry for Longhorn to the IP address of my load balancer. Save that, and now I should be able to access the dashboard using Longhorn name. HTTP Longhorn. There we go. So that's our dashboard. All right. So now let's explore the dashboard. So we've got the list of volumes here. At the moment, we don't have any volumes, and the amount of storage that can be allocated using Longhorn, and the number of nodes. So we've got 2 worker nodes. So it's showing 2 nodes that are schedulable, and we have about 161 gig of storage that can be scheduled as volumes. We don't have any volumes at the moment, so that's the dashboard. And down below, you've got the list of events, basically the event log of what's happening, what has happened so far. And then if you take a look at the node, we've got 2 nodes. You can expand by clicking on the plus icon here. It shows the list of disks configured for those nodes. And you've got the volumes. We don't have any volume. We'll create a volume shortly. And backup, we'll come to backup later, maybe in a different video. But in order to take a backup, you need to configure a permanent backup, a persistent backup store. It could be Amazon S3, AWS S3, or it could be a separate NFS server somewhere, but you need to configure the backup target before you can actually take backups. And there is this setting tab here where you can configure a whole lot of things, which you can also configure from the Helm values file that I showed previously. Okay, so let's go back to the dashboard and let's try and create a volume. But before that, let me show you the nodes tab. So we've got 2 nodes. Both of them are ready. You can select the node and you can edit, you can disable node scheduling, basically, which means Longhorn won't provision any volumes on this particular node. So you can selectively choose which machine you want to schedule the persistent volumes on. So edit the node. I'm gonna re-enable that. Okay, so we've got 2 nodes in ready status. There are no replicas at the moment. The amount of storage that we can configure, let's go ahead and edit one of them. So here it says node tag. You can attach a tag to your node. For example, let's say this node is in availability zone 1, and you can see the tag appearing here. And similarly for the second one, I'm going to say it's AZ2, and you can see the tag. It will be quite handy later when you're creating volumes. You can choose specifically which set of nodes you want to target while you're creating a volumes. Okay, and I'm going to go back to the edit page here again. And you can see here there's 1 disk configured at the moment. If you want to add more disk, you can add. Click on this add disk, and basically you give the path on the Kubernetes node where you mounted the volume. The proper use case would be you can attach an extra disk, an additional disk on your Kubernetes node, format it using ext4 or XFS, and then mount it under a certain path. That's the path you need to give here. Let's say you attached a new disk, formatted it, and you mounted this under data on your Kubernetes node, and you can call this disk as disk2, and you can also attach tag. Let's say this is an SSD, you can attach disk and so on, but I'm not going to do that. But this is the flexibility that you get. You can attach more disks on your Kubernetes node and then configure them here in this page. All right, so volumes, let's try and create a volume. Create a volume, let's call it demo size, say 1 gigabyte, and number of replicas. So this is important. So how many replicas of your volumes you want? You always choose more than one replica if you really want that redundancy. Okay, in case a node crashes, you want to make sure that your data is still available on one of the other nodes. Right, front end, block device ISCSI, and access mode read write once. Node tag. So this is where I specified the tag for the node, so you can basically choose. So at the moment we only have one machine in AZ1 and one machine in AZ2, but if you have more number of Kubernetes nodes and if you want to target based on certain tags, then you can use the tags here. Create that, and it says the volume is getting created. So the volume is created, but it's detached. It's not being used by any of the pod. The volume exists, but it's not being used by any of the pod. So back in the terminal here, I can do kubectl get volumes -a. So you can see here volumes, so that one is a CRD, custom resource definition, that was created when we deployed Longhorn. So we've got a volume called demo in the Longhorn storage namespace, and state is detached, size is about a gig, scheduled is true. And if I do CRD and grep for Longhorn, just to show you the bunch of the list of CRDs, custom resource definitions, that gets created when you deploy Longhorn. So volumes is one of those. So you can do kubectl get volumes. It actually gets created in the Longhorn storage namespace. So we have that volume created, and you can select the volume and you can expand the volume, update access mode, and all those things. You can delete the volume here, and you can also delete the volume here. But before that, let me go into the volume to show you a little more details. So I've got volume details here, the size, access mode, and everything. And once you create a persistent volume claim, you would get all those details down here. And this one shows the list of nodes where the replicas have been created or will be created. Snapshots and list of snapshots and backups. Recurring snapshot and backup. This is where you set up the recurring snapshot and recurring backups. So this one here shows the list of snapshots and backups, and down here you see the list of events. At the moment we don't have anything. I can delete the volume right here, select and delete, or I can delete the volume here. kubectl get volumes, kubectl -n Longhorn storage, delete volume demo. All right, so that's gone, and back in here the volume is also gone. Let's do a quick PVC, persistent volume claim. For that, I'm going to go to the Kubernetes documentation, search for PVC, and let's create a persistent volume claim. I'm just testing by creating a persistent volume claim. I'm expecting the Longhorn storage engine to create a persistent volume, but I forgot to show you the storage class. If I show you kubectl get storage class, I didn't have any storage class before, but once I deployed Longhorn, I now have a storage class called Longhorn, and which is also a default storage class. So when I'm creating a persistent volume claim, I don't have to specify the storage class since this is the default one. So let's try and create a persistent volume claim. This, all I need is this bit here. Copy, temp, let's call it pvc.yaml, paste that here. Right, I'm going to change the name to my PVC. Access mode read write once, that's fine. I don't need the volume mode. Resource request, let's say I want a gig. All right, that's all I need. I'm not specifying the storage class. That's all it's needed. kubectl apply -f temp pvc.yaml. So I've created the persistent volume claim. kubectl get pvc, and you can see already it's been bound to a persistent volume. And if I do kubectl get pv, so that's the persistent volume that got created. And I can also do kubectl get volumes -a, and you can see the name of the volume that was created for me. So that's same as this one, 5E5, and it's detached. Yeah, 1 gig, scheduled true. Right, back in the Longhorn dashboard, you can see the volume that was created here. It's detached, 1 gig, right? So everything is looking good. If I go back to node, and you can see now the number of replicas is 1. The volume that was created, this volume was created in both these nodes, and I can go to dashboard. Now we can see this 1 volume which is detached and 2 nodes. Okay, so now let's create a pod that makes use of this volume. Again, I'm going to go to the Kubernetes documentation. If I scroll further down, there should be an example. Let's copy this. Let's create another file, temp.pod.yaml, and paste that here. So let's leave the name to be my pod. Container is my front end. Right, mount path, I'm going to change that to /data, and the persistent volume claim. The persistent volume claim that we just created is my PVC. So that's all I'm going to do. It's just a simple Nginx pod that is going to use the persistent volume claim that I created previously to create a volume, and then mount that under /data in the Nginx pod, and the pod is called my pod. Right, save that, and then kubectl apply temp pod.yaml. Right, kubectl get pods. The pod container is getting created. Let's give it a few more seconds. Kubectl get pods. Still container is getting created. All right, cool. So now the pod is actually running, and if I go to the dashboard, and you can see there's 1 volume, and the state of the volume is in degraded state. All right, so I can see the node and look at the volume. The volume is in a degraded state, and it says the volume cannot be scheduled. Okay, and you can see here attached to my pod on kworker1. And back in here, if I do kubectl get pods -o wide, I can see it's in kworker1, and the volume is attached to my pod, but there's something wrong with the pod, the volume, and let's go dig deeper. So as you can see here, kworker1, it's fine, the volume has been created. Kworker2, it's been created, but there is a third node which can't be created because we only have 2 worker nodes, and the third one is the master node where we didn't configure anything. We didn't make sure the prerequisites are there or anything. But the problem is, in my Kubernetes cluster, the master node has got taints associated, so the Longhorn deployment wouldn't have deployed anything in the master node. So the way to fix this is I'm going to edit this volume and update the replica count. So I don't need 3 replica, I only need 2 replicas because I only have 2 worker nodes, and reduce the number of replicas to 2. And if I click OK now it says the health is healthy, state is attached, and everything is looking good. Okay, so if you want to make this the default, the number of replicas to be 2 to be the default, then you can go to the settings, general, and somewhere here you should have that. Yeah, default replicas count. I can set that to 2. Right, so back to the volume. We've got a volume that's healthy and it's attached to my pod. And here, so that's the current state of the volume. And if you look in here, the attached node is kworker1, but it's also being replicated to kworker2. And down here, you can see additional details, the persistent volume claim. The my PVC is the persistent volume claim that we created, that created this volume. Status bound and pod status is running, and all those details, right? And you can also look at the event log here. All right, cool. Now let's take a look at the pod. kubectl get pods, my pod, and I can exec into my pod and open a bash prompt, cd to /data. So that's the mounted volume, and I can touch a file. Let's say I've created a file called file, okay, and exit out of the container. And back in here, what I'm going to do is I'm going to create a snapshot. All right, so I'm going to click on here, and there's a take snapshot button, or you can click on this button, take snapshot here. Right, cool. Snapshot is being taken and it's done. So we've got a snapshot, and now back in here, if I exec into the pod again, cd to /data, and I'm going to remove the file. Okay, so the file is gone, but I've took a snapshot of the volume. The current state of the volume doesn't have that file, okay? And that has been replicated to these 2 nodes as well. So now, in order to restore the snapshot, what I need to do is down here, if you see there's a list of snapshot here. So the one snapshot that we just created. And in order to revert the snapshot, all I have to do is click on this, and the revert option is blanked out. Which means we can't revert a snapshot while a volume is attached. We need to detach the volume before we can revert the snapshot. So for that, I need to kill the pod, kubectl, delete pod, my pod, kubectl, get pods. Okay, so the pod is gone. Back in here, the volume is now detached. I need to attach this volume to a node, kworker1 or kworker2 in the maintenance mode. Okay, and it's being attached. So once that's attached, go into the volume, and now we should be able to revert to the snapshot, and the revert option is enabled. Revert, confirm snapshot, revert. Okay, right, snapshot is reverted. And again, I'm going to go back and detach this volume. Okay, volume detached. And now I can create the pod again. The pod is getting created. Container is getting created. Let's give it a few more seconds, and then we should be able to see the file, because we just reverted the snapshot. So while the pod is coming up, if you want to take scheduled backups or scheduled snapshots, place to go is here, recurring snapshots and backup schedule. Click on this new, and then you could either create a scheduled backup or a scheduled snapshot. As I told, in order to create a backup, you need to create a backup store. You need to configure a backup store, which I might do in a separate video, but for this video, let's say I'm creating a recurring snapshot and retain it for, let's say, for like 7 days every day. And if you want, you can change the cron entry, or there's also a GUI option that you can choose if you're not familiar with the cron schedule and so on. Right, I'm going to delete that. Let's see how the pod is doing. Okay, the pod is running now. I can exec into the pod, cd to /data, and that is my file. So that's how you can take snapshots, revert snapshots, create backups, create scheduled backups, incremental backups, and so on. What you can also do now is, if the node goes down and the memory is connected to kworker1, if kworker2 goes down, if kworker1 goes down, you can attach your pod to kworker2, and you will still have access to your data, and then when the kworker1 comes back online, it will resync from the kworker2. So that's the reason I would advise you to have more than 2 replicas at least like 3 replicas. All right, I think that's all, and let me know if you've got any questions. I'll be happy to help, and I will see you all in my next video. Until then, keep learning and keep on learning. Bye-bye.